Okay. First of all, there's not a quiz today on this stuff because we're not working with this stuff today. We will be working with that stuff on Monday. Did you catch that?
Where's that one?
I didn't say that. Alright, we're going to do U substitution, which is basically chain rule backwards. So, I'm going to show you the way that you will do this in college. And then I'm going to show you kind of like my shortcut way of thinking about it. So I used to just show like the shortcut way of thinking about it, but then I got people coming back from college, you know, like more than 9, 12, whatever, and they would say, teach U substitution. Like your shortcut works, but I had to like learn U substitution. So I'm going to show you both, and then you can kind of choose, like, do I want to stick with the college method that'll work for like more advanced problems, or do I want to use this like shortcut thing? It doesn't make a difference to me. They both work. It's just kind of whatever you prefer. So I'm going to start with the U substitution, which is like the technical college proper way to do it, and then this reverse chain rule is like my shortcut on it. So you can know what's coming. So let's start with just like reminding us what chain rule is. So just regular forward derivative chain rule says the derivative of f of g of x it says U substitution. Remember, we would say you take the derivative of the big guy, so f prime, you leave the little guy alone, and then you multiply by the derivative of the little guy, right? Or an example of, like with a problem, if I gave you, like, take the derivative of, 4x squared plus 3 to the fifth, so what's the big guy there? 5 right to the fifth, so I'm going to take the derivative of that big guy. Leave Mr. Packard alone. And then multiply by the derivative of Mr. Packard. That's chain rule, right? So we're going to reverse that. People get a little flustered by... So when we did chain rule, like this 8x kind of came out of nowhere, right? Like I took the derivative of the big guy, that's the 5 and the 4, and then I was like, oh, now you got to multiply by the derivative of the inside, so we're going to put this 8x. And like no one said a word, and everyone was like, okay, that makes sense. Well, in reverse, and when we go backwards, it's going to disappear. And like that freaks people out. So when I made it appear out of nowhere, everyone was like, oh, cool, that's totally fine. When I make it disappear, everyone's like, whoa, wait, what's going on here? But it's the same thing. It's the same, it's disappearing because it appeared. We're just doing it in reverse. Let's just start doing something. So let's say I gave you 4x to the third plus 8 to the fifth times 12x squared times the x. That head is really annoying me where it is, but moving it is going to take so much effort. I don't know if it's worth the battle. Oh, that's not what I meant for someone else. I'm sorry. That seems like I was passive aggressively telling someone else. I was just trying to express my inner battle. Okay. So what you're going to do, this is the U substitution college method. You're going to find the little guy, and you're going to assign it the value of U. So the little guy is the part inside the parentheses, right? Like it's what's being raised to the fifth power. So we're going to go get U is 4x to the third plus 8. And what we're going to do is rewrite the entire problem in u's. It's going to make it a lot easier to do. We're going to do it, and then we're going to put the x's back. So from here, I'm going to go, okay, the derivative of u with respect to x, so du over dx. The derivative of u, this is like dy dx, but we don't have y, we have u, so it's du dx, is 12x squared. Agree? From there, I can take another step. Let's say I multiply both sides by dx now, and it'll say du equals 12x squared times dx. Is it with me? Well, now I can rewrite the original problem. And what is 4x to the third plus 8 now? It's u. So now I have u to the fifth. And what is 12x squared times dx? Now it's du. Still with me? Or I just lose me? No, I lost you, or no, you're not. So, it's true now because I have made it so that u and 4x to the third plus 8 are the same. So instead of putting the 4x to the third plus 8 there, I'm just going to put a u. So that becomes u to the fifth. Because of this, I worked through and found out that du is the same as 12x squared times dx. So instead of this 12x squared times dx, I'm going to put the du. Alright? Now this is easy to integrate. What? I'm good? Okay. What's the integral of u to the fifth? Well, I'm going to add 1 to the power, multiply by the reciprocal, put my plus c. But the question was presented to me with x's in it, so I need to get my answer with x. So now I just replace, like I put the x's back. So, what is u? Well, u was 4x to the third plus 8. Right. So, we can always check it. If we take the derivative of this, what should we get? We should get the same thing we started with, right? So, bring down the 6 times 1 6, what happens there? Cancel out. And the 4 to the x to the third plus 8, you reduce the power by 1. You multiply by the derivative of the inside. And that's what we start with. So this 12x squared basically ends up disappearing, which makes everybody uncomfortable. Even though everyone was totally cool with it when I made it disappear. How'd that go? Does that seem reasonable, alright? That's like the dx. In the, you know, if I had like x times dx.
Right.
So, I haven't really explained what that is to you yet. That's that kind of thing, right? I'm going to keep it there for now. Is that fair enough for now? I can show you like visually later if you want. Okay, so let's try the integral of. No, I'm still in u substitution mode here. That's what?
Times 8 before the dx. Just do the chain rule again.
No, I don't do the chain rule again. I've got one big guy and one little guy. Well, I'm just writing the problem at this point. You don't know what the... But if I'm doing chain rule, I just do it once, but not like over and over until I get to what's wrong. Is that what you're trying? Is that what you're getting at?
Yeah.
Okay. What's your question? Oh. sorry to interrupt you. Conversation. So you assign u to be the little guy. So u is going to be 4x squared minus 6x. Is that fair enough? Are we good on how I'm getting the little guy? Okay. And then the derivative of u with respect to x, so this is like dy dx, but we're in u, so it's d dx. Becomes 8x minus 6. And then if you multiply both sides by dx, you get that du is 8x minus 6 times dx. You probably will stop writing this step after a while. You might have already, I don't know. That stuff's not really necessary. I'm just trying to show you how it works together. And now I'm going to go back to my original equation and rewrite it, but not with x anymore, with u. So instead of putting 4x squared minus 6x, what am I going to do? I'm going to put u. That 2/3 power is still there. And then instead of putting 8x minus 6 times dx, what am I going to do? D. Fair enough? We okay? Now integrate. So add 1 to the power. Multiply by the reciprocal of the new power. Don't forget your plus c. And then don't give me your answer like that. The question was presented in terms of x's. Give me the answer in terms of x's. So 3/5 times 4x squared minus 6x. So 5/3, and then plus. I told you to do it, and I did it. Sorry. How many got to that before I did? I didn't really leave much time though. Any questions on it? Let me give you one where I actually shut up and let you do it. Am I still writing this? It's not like 6th root, I just wrote it weird. Got it. Plus. Okay. So I would probably start by going, well, that's really 6x minus 4 to the 1/2. And then my little guy is the 6x minus 4. Is that part okay? Like, is it easy enough to figure out what the little guy is? For now. It does get harder when I start trading and ease and all that stuff. Then I'm going to go, okay, du is then 6 times dx. So I'm skipping that. du over dx. And then I'm going to plug back in. So 6x minus 4 is u to the 1 half. And then the 6 and dx are just kind of separated now, but 6 times dx now has the value of du. So now I can integrate. So add 1 to the power is 3 halves. Multiply by the reciprocal is 2/3. And then plug back in. That's your answer. How many of that? Questions on that one anywhere? I got something different. I think it's weird going through it yet.
So, 6, what is the 6?
So the 6 dx together has the value of du. So I just replace them both with du. So like in the previous process, it was written like right next to it, so it's easier to see, but it's the same idea. Other questions? So they're not always set up that friendly, because in every case they're just magically we can just plug in whatever we needed to and it works, but it's not usually the case. So you'll get more often something like this.
Yeah.
What?
Yeah.
No, I don't think you know how to do it yet. I was waiting for people to write it. So I'm going to start off the same way. I'm going to go, okay, u is going to equal 4x squared minus 4. But then what's d? It's 8x, right? 9 times dx? Well, I don't have an 8x. So this 4x squared minus 4 is going to plug in there. So this is like supposed to be an 8x. That's supposed to be, it'd be ideal if that were an 8x, but it's not. So I have to adjust this to make it fit this derivative out here. So this needs to be 2x times dx. And I just got to kind of think through, well, what did I do to that 8, that 8x, to turn it into a 2x? What did you multiply by? 1/4. So if I take 1/4 of both sides of the equation, that gets me to this 2x times dx that I need to have. When I had 8x, it was too big, it didn't work. So you're going to multiply by some constant to make it work. It might be 1/4, 1/3, it could be 3, 4, 5. They would make it bigger or small. But you've got to fit into what the problem presented. So now I'm going to go plug in. And in place of 4x squared minus 4, I put u. That's to the 1/3. And in place of 2x times dx, now I got to put this 1/4 du. So it's easiest, I think, to put the 1/4 out in front and the du after. Should I run through all that again? See what got? Now integrate, plug back in. So that's the hard part. So then add 1 to the power would be 4/3. Multiply it by 3/4. You already have 1/4 out there, so now it's 3/16. Plus c. And then plug your x's back in. So 4x squared minus 4. Question on that? Can I move it, or are people still writing? Still writing. Am I going too fast? Yeah. Yeah, what?
I just don't see where we go. Like, why do we put the 3/4 out?
Well, it's not really out front necessarily. It's just I added 1 to the power and got 4/3.
Yeah.
Then I got to multiply by 3/4. So I mean, I can write it wherever I want. I'm just doing 3/4 times
Yeah.
whatever that was already there. Is that over? Is that not what you're asking?
Yeah, it's just.
Like if I had x to the 3rd, 2x to the 3rd, let's say. And I'm going to integrate it. So I add 1 to the power.
Yeah.
Then I multiply by the reciprocal of the new power. Times the 2 that's already there, though, right?
No, 1/2.
1/2. But that's all I'm doing. It's just multiplying by the number that's already there. So u is going to be the x squared minus 6. And then du would be 2x times dx. But 2x times dx doesn't fit in there. I've got to turn it into 10x times dx. So what do I multiply the right hand side by? So you got to do the left hand side by that also. So it becomes 5 times du equals 10x times dx. That part good? That's the hard part. So I'm just like, please ask me this question. I think that's the hardest part. Then I'm going to rewrite everything up here. So instead of this, what am I putting? It's u to the 1/3. And instead of this, what am I putting? 5 times du, right? It makes most sense to me to write the 5 out in front because that's just how you're used to seeing the problems that you're integrating. How many got to this part of this? Okay. Now integrate. Add 1 to the power, so that becomes 4/3. Multiply by the reciprocal of the new power, so 3/4 times 5 is 3/4 times 5 is going to go out there, so 15/4 plus c, and then put the x's back. So it's like we kind of cheated and put u's in, and then you got to pretend that you did the whole problem in terms of x's. Oh look. How many got that answer? Nice. Question time. So just like a sneak preview of what we're doing with the trig and stuff, so try this one. You might be able to do this right now. I don't know. But these can get pretty goofy. There can be double layers. I can have trig and powers. I can have e's, ln's, kind of all involved. So u is always the little one. So that's where you start. And I haven't really done it with trig, so if you don't get it, I wouldn't worry about it. But just thought I'd throw it out there. So you would say u equals 4x. Du would then be 4 times dx. Well, you don't have 4 times dx, you just have plain dx. So I got to get rid of the 4. So what do I multiply by to get rid of that 4? Multiply everything here by 1/4, so you'll get 1/4 times du equals dx. Then if I go rewrite, now it becomes the integral of sine of u, and then dx now has the value of 1/4 times du, so I throw the 1/4 in front and the du out there. What's the integral of sine? Negative cosine, so you have negative 1/4 cosine of u plus c, and then you would put the x back in there, pretending it was there all along. Everybody get that? That's a little tough, right? I haven't gone through it yet, but same idea. Questions I can answer in any of this concept? I'm actually not going to show you reverse chain rule yet. So on here, I gave you the first 10. I put on there what u is. And then the last 10 I did not. So there's like a... The first 10 a little easier because I told you u, and the next 10 gets up there. So on Monday, we will be doing this with trig and e's and ln's. You will need to know those. I will be making sure that you know those before we start.
Okay.
Is the
Hint.
What did we do? Oh, yeah, yes, it is. And I talked about corrections. So if you want to do corrections, I'm going to do it through those things. assign some con too to practice the same stuff.